Welcome to this video on order of operations with rational expressions. What do you think of when you think of order of operations? What comes to mind? Often, what comes to mind is PEMDAS, or please excuse my dear Aunt Sally. In this memory trick, the P stands for parentheses, the E stands for exponents, the M stands for multiplication, D for division, A for addition, and S for subtraction. Now, this is a convenient memory technique, but it can be somewhat misleading. What do I mean? Well, the first order of operation is parentheses. We do that before anything else. Then we have E for exponents. But something that's not necessarily mentioned is that we also need to include roots in our exponents. Then we have multiplication and division from left to right. And this is where it gets a little bit tricky. Since the M comes before the D, most students rightly assume as one would, that multiplication is before division. But the truth is, multiplication and division have the same level of precedence. Okay, they have the same priority. So if I come across division before multiplication, I'm going to do that first. And if I happen to come across multiplication for division, that's okay too. I will do that first. Okay, so again, even though M comes before D in PEMDAS, okay, M and D are actually together. They have the same level of precedence, the same priority. And the same thing is true for addition and subtraction. Again, we say Aunt Sally, addition, subtraction. So it sounds like addition comes before subtraction. Again, this is just a tool. This is just a memory technique. The truth is that if subtraction happens to come before addition, we would need to do that first because addition and subtraction have the same priority. Okay, so please keep that in mind as we work through some of these problems. Let's begin. So here's example 1. We have 1/2 plus 3/5 times 5/7. So over here in the corner, I have a little memory technique. So we don't have any parentheses. We don't have any exponents. We do have either multiplication or division. Specifically, hopefully you can see here, we have a multiplication of 2 fractions. So I'm going to do that first. So remember, when we multiply fractions, we just multiply straight across from left to right. So 3 times 5 is 15, and then on the bottom, 5 times 7 is 35. Okay, so now I have 1/2 times 15 over 35. Now, let's pause for a second and see if there's a different way that I could have solved this or thought about this. Another thing you might notice is that these 5s cancel out. So one thing I could do to make my life a lot easier is that I can reduce 15 over 35 by dividing both the top and the bottom by 5. I can reduce that to 3 over 7. Okay, you don't have to do that. I'm not telling you that you have to do the problem that way. You could probably do it a different way and still get the same answer at the end. But to me, this is a lot easier to work with, to reduce first and then keep going. So now I have 1/2 plus 3/7. So now we're on our final stage, which is, of course, addition and subtraction. Now, unfortunately, addition and subtraction of fractions is actually a lot harder, right? It's more work than multiplication or division. What we have to do if we want to add 2 fractions with different denominators is that we have to get our common denominator. So the easiest way to do this is to multiply 1/2 by 7 over 7 and to multiply 3/7 by 2 over 2. So if you forget how to do this, please go back to this section where we learned how to add and subtract fractions and review this, because this is material that's already been covered. So 1/2 is the same as 7 over 14. 3/7 is the same as 6 over 14. So now we can add across. 7 plus 6 is 13. And of course the denominator doesn't change, so we get 13 over 14. That's our final answer. Again, if you need any review on any of this, how to reduce fractions, how to add or subtract fractions, how to multiply fractions, please go back to those sections and watch those videos. Okay, so let's do the next example. So this next example is here. Okay, so again, we do not have any parentheses, we don't have any exponents, we only have multiplication and division. So remember I mentioned, right, that we have to do multiplication and division from left to right. They have the same level of precedence. So the division part actually comes first, so we're going to do that first. So I have 5/8 divided by 9/10. Now if you remember when we learned about multiplying and dividing fractions, in order to divide fractions we actually have to change it to multiplying by the reciprocal. So 5/8 divided by 9/10 is the same as 5/8 times 10 over 9. And then I'm going to just go ahead and bring down the rest of the problem, because a very easy mistake to make in these sorts of problems is to forget and then to only do part of the problem just because you didn't transcribe it. Very easy, happens to be. Okay, so let's take this first bit. So remember, when we're multiplying fractions, we can just multiply across. So 5 times 10 is 50, and 8 times 9 is 72. Okay, so at this point, you have two options. You can just, bring down the 3 over 7 and keep going, keep multiplying. You might realize, however, that there is a way to reduce this. 50 over 72 can be reduced. They're both even numbers. So I could actually reduce that by dividing by 2 first if I wanted to. That would give me 25 over 36. Okay, again, if you want to do that first, or multiply and then simplify, it's up to you. I'm going to simplify first. It just makes it easier. All right, so then we can multiply straight across. 25 times 3 is 75, and 36 times 7 is, let's see, 36 times 7 is 252. Okay, so that is going to be not our final answer. Uh-oh, why is that not our final answer? Well, look, I have a 3 up here and a 36 down here. Both of those are divisible by 3. So this can become a 1 and a 12. Okay, so just looking at the fraction 75 over 252, honestly, I might not have realized that both things were divisible by 3. That might not have occurred to me. But looking at 3 and 36, I definitely can tell that that's true. So this gives me 25 over 84. So that is our final answer. Okay, and again, if you forget how to multiply fractions or divide them, if you forget how to reduce fractions, please go back to those sections. All right, let's do another example. So this time we have 3/8 times the quantity 5 over 6 minus 1 over 4. So notice I said the quantity, meaning that there's parentheses. So we do have parentheses this time, so we definitely need to resolve those first before we do anything else. Unfortunately for us, those fractions inside the parentheses do not have the same denominator, so we're going to have to do a little bit of magic here and make them have the same denominator. You might remember that you have to find your LCD. Your LCD in this case is 12. So we can make them both have a denominator of 12 by multiplying 5/6 by 2 over 2, and by multiplying 1/4 by 3 over 3. Again, I want to make sure that I bring the whole problem down. I'm going to bring down the 3/8 out here and transcribe that every step of the way, because I know myself and I know if I don't do that, I'm going to forget it's there. Okay, so remember, when we multiply fractions, we just multiply across. So 2 times 5 is 10, 2 times 6 is 12, 1 times 3 is 3, 4 times 3 is 12. Okay, again, bring down the 3/8 times. And in parentheses, 10 minus 3 is 7. So we have 7/12. You're free to transcribe the parentheses if you want to, but you certainly don't have to. Okay. So again, if you wanted to, you could just multiply across. However, that might be, if I do that, I might not realize that there's stuff I can reduce. But looking at this, I can see that 3 over 12 reduces to 1 over 4. So I'm going to choose to reduce first, to save myself a lot of time and bother, and so that, I get the correct answer. Okay, again, if you wanted to, you could do 3 times 7 is 21, and then 8 times 12 would give you 96. Okay, you can do that, but then you would have to realize, oh, they're both divisible by 3, and then you'd have to divide top and bottom by 3 to get the correct answer of 7 over 32. Okay, you always, always, always have to reduce your answer. All right, so we did our parentheses. We didn't have any exponents. And then once we simplified what was in the parentheses, then we did our multiplication, right? And then there was no division, and the addition and subtraction was already in the parentheses. So we're done. All right, let's do this next problem here. So again, we have our parentheses that we have to deal with, and just like last time, the fractions that are inside the set of parentheses unfortunately do not have the same denominator. So we have to find an LCD. So what is the LCD of 9 and 6? In other words, what is the smallest number that is divisible by both 9 and 6? The answer is 18. You don't have to use 18. You can use any common denominator. It does not have to be the smallest one. So to transform 9 into 18, I'm going to multiply by 2. To transform 6 into 18, I need to multiply by 3. So 2 times negative 2 is negative 4. So I have negative 4 over 18 minus 3 over 18. And I still have divided by 14 out here. Okay, so I have negative 4 minus 3. That gives me negative 7. So I have negative 7 over 18 divided by 14. Okay, so we've done our parentheses. There are no exponents in here. Now the only remaining operation is division, so we have to do that. So remember, we kind of don't really know how to divide fractions. We only know how to multiply by their reciprocal. So you might be thinking to yourself, well, gee golly, 14 isn't a fraction. But remember, you can always make a whole number a fraction by simply placing it over 1. And when you do that, it makes it a little bit more obvious how to rewrite this as a multiplication problem. I can rewrite it as negative 7 over 18, sorry about that, 18 times 1 over 14. Okay, and again, to save myself a lot of trouble and bother in the future, I am going to reduce this. 7 goes into 14 twice, so 7 over 14 reduces to 1 over 2. Okay, there's still a negative sign there, so I have negative 1 times 1, so negative 1 on the top. 18 times 2 is 36, so I have negative 1 over 36. All right, let's do another example. Okay, this time we actually have some exponents, which is exciting. We have parentheses, but the parentheses again are just sort of acting as grouping symbols for the exponents. So let's evaluate this. So 3/4 quantity squared is 3 squared over 4 squared. Of course, there's a 6 out here. And remember, anything raised to the 0 power is 1. Okay, so 7/8 to the 0 power is 1. Okay, so I still have to do my exponents first. So I have 6 times 9 over 16 minus 1. That's a times. Okay, so I have a few options here. First of all, just to make myself more comfortable, I'm going to write a 1 here. That'll make me feel better. Okay, 6 and 16, I can take a 2 out of both of those. 6 divided by 2 is 3. 16 divided by 2 is 8. So that's one way I can reduce that. So 3 times 9 is 27. So I have 27 over 8 minus 1. So we've done our parentheses, our exponents. We've done our multiplication. There wasn't really any division other than the fraction itself. So now we have to subtract these rational numbers, which is annoying, right? Because one of them has a denominator, one of them is a fraction, and one of them is not. So the easiest way to fix that is just to multiply 1 by 8 over 8. So it's like cutting one whole pizza into 8 equal slices. So we have 27 over 8 minus 8 over 8, and that leaves us with 19 over 8. And that's it. All right, let's look at this next example. So we have 9/4 times the quantity of negative 2/3 plus 1/2 quantity cubed. So again, we always start with parentheses. I think this is a little bit misleading because you have to ask yourself, what are the parentheses really doing? So in this case right here, the parentheses are really only indicating multiplication. Over here, the parentheses are grouping the 1/2 so that we can apply the exponent. So this is really just multiplication because there's not more than one term inside the parentheses, and this is really exponents. Okay? So because these two things are joined with addition, it actually kind of doesn't matter which one we do first, but just for the sake of being thorough, let's look at the exponents. Let's do the exponent piece first. Okay, so 1/2 quantity to the 3rd power is 1 to the 3rd power over 2 to the 3rd power. Okay, and then we can go ahead over here and multiply. So we have 9 times negative 2 is negative 18. 4 times 3 is 12. Okay, you might notice that negative 18 over 12 can be reduced. Both of those are even numbers, so I could divide by 2 up here and down here and reduce it to negative 9 over 6. And then over here I have 1 over 8. You might think to yourself, I can reduce it even more. 3 goes into both numbers. So you have negative 3 over 2 plus 1 over 8. And at this point, I think we have to go ahead and actually do the addition and get a common denominator. So we need to get an 8 on both sides. So 4 times negative 3 is negative 12 over 8 plus 1 over 8. We add across, we get negative 11 over 8. Okay, and just to remind you guys, if you wanted to do it a different way, another way to do it would be to reduce here. So 9 divided by 3 is 3 over 1. 2 goes into both 2 and 4, so this could become a 1 and that could become a 2. So right out of the gate, if you had wanted to, you could reduce before you multiply, and that would have given you negative 3 over 2, which is, of course, the fraction that we ended up with anyways down here. So if you want to simplify first that way, before multiplying across, please feel free to do that. Whichever way you're more comfortable with is fine. All right, let's do another example. All right, so this one is kind of interesting in my opinion. This one uses this division bar as a grouping symbol. So in other words, with this long, that's a horrible way to say it, it's not long division, but this division bar that's very long and goes under a bunch of terms is it's grouping this top bit together. So it's acting as a set of parentheses, right? It's grouping the top bit together, and then it's grouping the bottom part together. So it's not really, we don't really mention that symbol in Please Excuse My Dear Aunt Sally, but you can treat it as parentheses. So we have to do just the top first, or if we wanted to, we could start with the bottom, and it doesn't matter, but we have to do them, one at a time before we put them all together. Okay, so let's look for some exponents. Hopefully you can see we have 2 to the third power. So we have 12 plus 2 to the third power. Well, 2 to the third power is 8. So we have 12 plus 8 upstairs. And then downstairs we still have 3 times 7 minus the quantity of 4 minus 2. Now I guess you could be yelling at me right now if you wanted to and be like, oh, wait a minute, there's exponents in the bottom. That's true. It's not exponents, there's parentheses in the bottom. So if you wanted to do the parentheses first, because they're there, you absolutely could. Again, we're going to be evaluating the upstairs and the downstairs completely independently. So from that point of view, it kind of doesn't matter. Okay. So let's look at the downstairs part. So looking at the parentheses, right, we have 4 minus 2. So 4 minus 2 is 2. So let's go ahead and do this. So we have 3 times 7 is 21. So we would have 21 minus 2. So we have 12 plus 8 upstairs. Again, 3 times 7 is 21 minus 4 minus 2, which is 2. Okay? And again, if you want to simplify the denominator first, because there's exponents there, that's totally fine. Either way, you're going to find out that you get the right answer. Okay, so 12 plus 8 is 20. 21 minus 2 is 19. Don't think that could be reduced, so that is our final answer, 20 over 19. All right, let's do one more problem. Okay, so again, with this problem, they don't really mention it or tell you, but this bar is acting as a grouping symbol. So we're going to almost treat the numerator, the top part, as its own problem, and the bottom part, the denominator, as its own problem. Okay, and if you want to evaluate the top first and then the bottom, that's fine. Bottom and then the top doesn't matter, as long as they don't really interact with each other until the very end. That's the main thing. Okay, so let's just go ahead and start upstairs. You can see that we do have some parentheses. Specifically, we have negative 9 plus 5. Negative 9 plus 5 is negative 4. So then I'll just transcribe the rest of this problem. And I'm not changing anything else, just copying it. Okay, so again, back upstairs, negative 4 divided by 4 minus 2. What do we have to do first, the division or the subtraction? Well, PEMDAS, right, says that division comes definitely before subtraction. So negative 4 divided by 4, I believe, is negative 1. So we have negative 1 minus 2. Okay. At this point, if you wanted to start messing with the denominator, that would be fine. Negative 4 quantity squared is the same as negative 4 times negative 4. Negative 4 times negative 4 is positive 16. So we have 16 minus 6 downstairs. So negative 1 minus 2 is negative 3. 16 minus 6 is 10. So our final answer is negative 3 over 10. Okay, and again, if you want to be a little bit more legalistic and follow, please excuse my dear Aunt Sally, that is fine. Again, as long as you evaluate the numerator independently from the denominator, that is the main thing.